Hi, today we've got Pearson Edexcel Functional Skills Maths Level 1. This is past paper 8 and we're going to start with the non-calculator section. Question 1. 7 times 13 equals 91. What is 91 divided by 7? Well, this is doing the inverse operations. So if we multiply by 7 to get 91, the opposite of multiply is divide, so that's going to get us back to 13. Okay. If you want to check that, you could do it using the bus stop method. So you say, how many times does 7 go into 9? Well, that's once with a 9, 2 left over. How many times does 7 go into 21? 7, 14, 21. That's 3 times. But hopefully you'd be comfortable with knowing that you can just do the opposite. Either way is going to be fine. Okay. Part B. Work out 4 plus 5 times 3. So we just need to remember which order we need to do these things. If you remember your BIDMAS rules, B stands for brackets, we haven't got any. I for indices, so like squared or cubed, we haven't got any. D for division, still no division. M for multiply, well, we have got multiply. So we're going to do the 5 times 3 first. Well, what I like to do is to rewrite it so the 4 isn't changing. Even though we're doing the 5 times 3 first, we're still going to have the 4 plus. It's just this calculation that we're doing first. Well, 5 times 3 is 15. Now we add on the 4. So I've not changed the order. I've still got these lined up nicely, but we just had to do the times before the add. So now we've got 4 plus 15. Well, 16, 17, 18, 19. And there's our answer. We can put that down here. And part C. Use a reverse calculation to show a check of your answer for part B. Okay, so reverse calculation. So we're going to start with the answer. Let's bring it down so we can see what we did up there as well. So we start with the 19. We added 15 to the 4. So if we minus 15, well, in fact, we can do that here. 19 minus 15. 9 minus 5 is 4. 1 minus 1 is 0. So we just get 4. Good. Now, we can also do reverse calculation on the 15 bit, because if we say, well, 15, we multiplied it by 3 to get 15. So if we divide by 3, well, let's try a 3 times table. 3, 6, 9, 12, 15. So that will take us back to 5. So we sort of did 2 checks there. I'd do both parts so that you're starting from your answer and going all the way back to what you started with. Question 2. Esme is putting copper tape around a flower bed in her garden. The flower bed is rectangular in shape. She has this sketch of the flower bed. Okay, so we've got, it's 175 centimetres wide and 110 centimetres deep. Or long, however you want to describe it. It doesn't matter which words you use, as long as we know we've got the 2 different dimensions. Esme wants enough tape to go around all the edges of the flower bed 3 times. Work out the length of tape Esme needs. Well, if it's going to go all the way around the edge, I'm just going to draw it on. It might be obvious to you, but I'm going to just draw these to show, well, we know this is 175 centimetres. This is also going to be 175 centimetres. And if this is 110 centimetres, well, this will be 110 centimetres as well. So we want to know how much tape to go round the flower bed 3 times. Well, let's work out how much we need to go round it once, first of all. Or in other words, what we're working out is the perimeter. So we're going to have 175 centimetres for the first length, then we're going to add on 110, then we've got another 175 at the bottom, and another 110 up the side. Okay, so this will give us how much we need to go once around the flower bed. So 5 plus 0 is 0, plus 5 is 10, plus another 0 is still 10. So put a 0 and carry the 1. 7 plus 1 is 8, plus 7 is 15, plus another 1 is 16, plus the one we carried is 17. Put the 7, carry the 1. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus another 1 is 5. So we've got 570 centimetres. That's to go around once. We want to go around the flower bed 3 times. So I'm just going to put a times 3 here. 3 times 0, 0. 3 times 7, 7, 14, 21. So put the 1 and carry the 2. 3 times 5, 5, 10, 15. Add on the 2, 16, 17. So we've got 1,710 centimetres. Question 3. Jeff is looking for car insurance. He must tell the insurance company the mean number of miles he drives his car each year. Jeff bought his car 5 years ago. Jeff knows when he bought the car, the mileage was 27,563. I'm going to put a comma in there, make it easy to read. Today, the mileage is 72,889. Work out the mean mileage each year for the last 5 years. Okay, so the mean is our average here. Well, we want to know how many miles he's actually driven the car, first of all. And we can do that by working out the difference between the mileage when he bought it and the mileage today. So in other words, what that means is we want to do 72,889 and subtract the number we started with to give us the difference. So 9 minus 3 is 6, 8 minus 6 is 2, 8 minus 5 is 3, 2 minus 7, well we can't take 7 away from 2, we haven't got enough. So instead we're going to reduce the 7 to a 6, and then we can give 1 to the 2. So this now becomes 12 minus 7, which is 5, 6 minus 2, which is 4, and we can put our comma in there. So we've got 45,326, and it's good to put the units in so we know what we're doing. That's miles. So that's how many miles he's used in the whole 5 years. We want the mean. Well, to work out the mean really is the total of whatever we've got divided by the frequency or how many. In this case, the total is the miles, 45,326. And the mean, the how many, well, this is for the last 5 years, so it's going to be the number of years. It's going to be that 5. So we want 45,326 divided by 5. So what we'll do is we'll do that using the bus stop method. So we put 45,326 in the bus stop, put a 5 on the outside. So how many times does 5 go into 4? Well, it doesn't, because 4 is less than 5. So what about how many times does 5 go into 45? 5, 10, 15, 20, 25, 30, 35, 40, 45. So that's 9 times. What about 5 into 3? 5 doesn't go into 3, so that's a 0. But we can carry that 3 across. So how many times does 5 go into 32? Well, 5 into 32. So we've got 5, 10, 15, 20, 25, 30. So that's 6 times. And 32, so we've got 2 left over. Okay. Now, how many times does 5 go into 26? So 5, 10, 15, 20, 25. That's 5 times, but we've still got 1 left over. So what we can do is make this point 0. So we're not changing the number, but we're just giving us somewhere to carry over our 1. Okay. We put our decimal point on top so it's lined up. So now we're saying how many times does 5 go into 10? Well, 5, 10, so that's twice. So we get an answer of 9,065.2 miles. Question 4. Jess buys sweets from her shop at a wholesaler's. On Tuesday, Jess sees sweets with a price of £147.65p. The price does not include VAT. Jess wants to estimate the total cost, including VAT. VAT is 20%. Okay, work out an estimate for the total cost of these sweets. You must show you're working. So the really important word here is estimate. Estimate. So what that means in this case is we need to round. So we don't want the exact answer. In fact, if you work out the exact answer, you won't get all the marks. So what we're going to say is, well, £147.65, that's approximately equal to, well, let's round that to the nearest 10 maybe. So that's approximately equal to £150. Okay. We want to work out what 20% is, so then we can add it on. Well, I know that 10% of 150, well, we just take the 0 off at 10%, so it's just going to be £15. So if I want 20% of £150, well, 20 is double 10, or like 10 and 10. So we can do 15 plus 15. So let's, what should we do that over here? So we can say 15 plus 15 or 15 times 2, doesn't matter. 5 plus 5 is 10. 1 plus 1 plus 1 is 3. So if 10% of £150 is 15, then 20% of £150 is 30. So this is our VAT. Now we want an estimate of the total cost, so that means the £150 that we started with plus the £30 VAT. 0 plus 0 is 0, 5 plus 3 is 8, 1 plus nothing is 1. So that's our estimate. And that's the end of the non-calculator section. So now we're on to the calculator section. Question 1. Russell wants to hire a cement mixer. He uses this formula to work out the total cost. So we've got the number of weeks, then multiply it by 20, add 15, and that gives you the total cost. Russell wants to hire the mixer for 4 weeks. He thinks the total cost will be less than £100. Is Russell correct? So let's test it out. So we've got 4 weeks. 4 weeks, and then we multiply it by 20. Okay, so let's do this with our calculator. 4 times 20, so that's 80. Okay, I'm doing it step by step. Okay, we're not going to use our BidMath rules here because we have to do this bit before we do the next bit. Okay, so 4 times 20 is 80. Then with the 80, we then need to add on 15, which gives us 95, and that's the total cost in pounds. Russell thinks the total cost will be less than £100. Well, £95 is less than £100, so is Russell correct? Yes, he is correct. Question 2. Rob throws a fair coin once. Write down the probability the coin lands on heads. Okay. Well, if you're tossing a coin, you've got 2 possible outcomes. Heads or tails. So there's 2 of them. We want the probability it lands on heads. Well, there's only one head, so it's going to be 1 out of 2 or a half. Part B. Write down the following numbers in order. Start with the smallest number. Right, so when we've got lots of similar numbers like this, or different number of decimal places, it can really help to write them one above the other and make sure that you line it up so we've got all our units, or in this case the zeros lined up, the decimal point lined up, the tenths, the hundredths and thousandths all in line. Now, that might not have helped you just yet, but what we can do is we can fill in the gaps at the end. So we can just put zeros in here. Now, because the zeros are the same for all of the numbers, we can actually ignore that and just say, right, let's just compare these numbers here. So we've got 400, 310, 371, 130 and 380. So what's the smallest? Well, that's the smallest. Next one is 310, then 371, then 380, and finally 400. So we can do this because they've all got the same whole number there, okay, which is 0. Right, so now we need to write them in order. Well, the first one was this 1, which was 0.130. The second one was this 0.310, but actually they just had it as 0.31, so we'll keep it in the format they've got it. Then 0.371. And fourth we had this 0.38 here. And the biggest one, 0.400, but they'd actually just given it a 0.4. Okay, question 3. Sorry, not question 3, part C. Here are two mixed numbers, 7 3/10 and 7 2/5. Which of these two mixed numbers is greater? Show why you think this. Well, they've both got the same whole number. So actually, we can ignore the whole number. It's going to be the same. We want to know, is 3/10 bigger or is 2/5 bigger? Well, 3/10, 2/5. So if we want to compare fractions, it's very difficult to do it when we've got different denominators. So we want to make the denominators the same. Now, 5 goes into 10. Okay, so that means that we can change this fraction so it's got different numbers but still have the same value. So what we say is, well, I want to rewrite this fraction as being over 10. Because then I can compare it to this one, because this is also over 10. It's got the same denominator. Well, if we want to go from 5 to 10, we're doubling, multiplying by 2. So if we're doing that to the bottom number, we need to do the same to the top number. So 2 times 2 is 4. Okay. And what we can do actually is with the calculator, I can show it to you that if we do 2 divided by 5, we get 0.4. And if we do 4 divided by 10, we also get 0.4. So these have the same value. But what it means is now we can compare these two and we can easily say 3/10, well, that's clearly less than 4/10. Okay. But the question was which of these two mixed numbers is greater. So we need to do this bit to find out our answer, but then the actual answer we're going to give is that it was the 7 2/5, which was the bigger one. Question 3. Mo has 5 hens in his garden. 12 kilograms of hen food costs £10.50. Mo knows one hen needs 150 grams of this food each day. Work out the cost of this food for the 5 hens for 1 day. Give your answer to the nearest penny. Right, so we've got 5 hens. They need 150 grams a day. So we're going to do 5 times 150. we get 750 grams. Okay, well, the price, we're giving it in kilograms, but we've got grams here. So what we can do is convert this. So I know that we've got 1,000 grams in 1 kilogram. So if we multiply this by 12, so we can say, we're sort of doing it backwards, well, 12 kilograms is going to be 12 lots of this, which will be 12,000 grams. Hope that makes sense. Now, what we want, we only want 750 grams. So what we can say is we want 750 grams out of 12,000 grams. So we're writing it as a fraction. Okay, and then we can multiply that by the £10.50. So we've got 750 divided by 12,000, multiplied by £10.50, which gives us 0.65625. We want it to the nearest penny, so we want 2 decimal places. So we look at this. This is, if this is 5 or more, we need to round it up. So it's going to be 0.66 or 66p. Okay. What we could do is we could do it slightly differently, and we could say, well, we know we've got 12,000 grams, costs £10.50. So what we could do is say, well, if we take the £10.50 and divide it by 12,000, that will tell us how much it costs for 1 gram. Okay, so 10.5 divided by 12,000, that's a cost for 1 gram. Okay, so 0.000875. Doesn't mean a lot on there because we've got lots of zeros, very small number. But then we need to multiply that. So this is for 1 gram. If we then multiply that by 750, we then get back to the same answer we had before. So this is just so we're still going to get 66p as the answer there, and this is just alternative method. But it might make more sense to some people this way because we're working out the price of 1 gram, and then this is the price of 750 grams. Question 4. Nazrin uses an app to record her sleep quality score. She has this information for last week. So Monday her score was 88, Tuesday it was 80, and so on. Nazrin thinks the range of her sleep quality scores for last week is less than 20. Is Nazrin correct? Show why you think this. Well, the range is the biggest value minus the smallest. So what's the biggest number we've got here? 88, anything bigger? No, so that's our biggest. And what's the smallest? 69, nothing smaller. Right, so it's going to be 88 minus 69. Which gives us 19. Nazrin thinks her score is less than 20. Well, 19 is less than 20. So, yes. She is correct. We've then got part B, show a check of your answer. Well, we can do a reverse check. So the answer we had was 19. And the way we did that was we had 88 minus 69 give us 19. Well, if we add the 69 back on, it should take us back to what we started with, which is 88. So there's our check. Question 5. Here is some information about the test scores of 40 students. So we've got, there were 7 students that scored between 0 and 10, 15 students that scored between 11 and 20, 10 that scored between 21 and 30, and 8 that scored between 31 and 40. On the grid below, draw a bar chart for this information. Right, so we want to, with the paper or the space you've got for the bar chart, you want to use at least half of the space that you've got. So you want to think about how you can best use that. Well, I'm going to have the test scores going across the bottom. And we've got 4 categories. So I think I can have 3, 4, yeah. So I can have 0 to 10 category here, 11 to 20 here, 21 to 30 here, and this last one will be the 31 to 40. So, and this is going to be our test score. So now for our scale up here, that's going to be the number of students. And the biggest number we've got is 15. So we've got to work out what scale to use. We could just say use one of these little boxes. 1, 2, 3, 4, but 15 would only be up here. So this wouldn't be a very big graph. So instead we can think, well, if we want 15, how else can we use these boxes? Maybe we could use these slightly bigger boxes. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 takes us up to the very top there. If I counted that right. So let's just double check. That doesn't feel right to me. Let's double check. So we're saying 1, 2, I'll mark it on 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's bring that down a bit. 11, 12, 13, 14. Yeah, I've done something wrong before. 15, 16. So that's why it's always good to be extra careful and check on these. So now we've got that scale there. I can draw my axis in. Right, now we need to start plotting our bar chart. So for the 0 to 10 category, we had 7 students. Right. In fact, we can write on that this is number of students. Okay, so 7 students. Well, this is 6, this is 8, so 7 is going to be in between here. So make sure you use your ruler for all your graphs. 7 there. For the 11 to 20 category, we've got 15 students. So 11 to 20 here, but we're going to have to go all the way up. So 15 is going to be halfway between 14 and 16. So draw that there. The next category, for 21 to 30, we've got 10 students. So 21 to 30, we want to go up to 10. And then for the 31 to 40 category, we've got 8 students. So 31 to 40, we go up to 8 students here. Now I'll draw my bars in. So you don't have to have your bars touching, but if you don't, you need to do more drawing. So I'm just being efficient and doing as little as I need to. And we can just give it a title, which will be test scores. Doesn't need to be anything more complicated than that. And we've got everything we need. So correct scales, labels, heading, all marked up nicely. Question 6. Steph wants to cover part of her garden with paving blocks. The diagram shows the part of the garden she will cover with blocks. The shape of this part of the garden has one line of symmetry, and all corners are right angles. Okay, so we've got our sketch here. We've got some of the measurements written on, but not all of them. And then we're told the paving blocks are sold in packs. Each pack covers 10 metres squared. Blocks can be cut and joined. Work out the number of packs Steph needs to cover this part of her garden. You must show your working. Right, well, we know how much space we can cover with one pack. So we need to work out how many packs. So that means we want to know the total space or the total area of this shape here. Well, to make it a bit nicer, I'm going to split this into rectangles. Because I know that the area of a rectangle is the length times the width. Okay, so we can use that. So for example, for this rectangle, the area is going to be the length, which is 9, times the width, which is 5. So 9 times 5, that gives us 45, and it's meters, so it's going to be meters squared because it's area. Now, for this one up here, well, we don't actually know what the length is just yet, so we need to work it out. Well, we know that this is 9 meters all the way across, and we're told that we've got one line of symmetry. Now that's really important because it's got a line of symmetry, we can use some of these other measurements. So first of all, where do we think our line of symmetry is? Well, it's basically a mirror line that's going to split the shape into 2, so it's going to have to be down here, something like that. So what that means is we know that this distance over here must be exactly the same as what it is over there, 1.75 meters. So if we want to work out this gap in between, well, we can take the 9 meters, which is the full length, take off 1.75 meters for that side, take off another 1.75 meters for that side, and whatever's left should be this distance here. Okay. We'll do the 9 minus 1.75, and then minus another 1.75. If you want to add the 1.75s together and then take them off in one go, that's fine. So we've got 5.5 meters. Let's just mark that on here so it's clear what that's referring to. So it's 5.5 meters. So the area of this rectangle is going to be the length, which is the 5.5, times the width, which is 3. We've already got 5.5 in here, multiply it by the 3, get 16.5, and again that's going to be meters squared because it's area. Right, so what we need to work out next is our total area. Okay, so where should we do this? Let's do it here. So total area is going to be 16.5, which is the area of the top rectangle, plus 45, which is the area of the bottom rectangle. So again, I've left this in my calculator, so I can just add on the 45. So we've got a total of 61.5 meters squared. Right. Each pack covers 10 meters squared. So if we divide our 61.5 by 10, that'll tell us how many packs we need. So 6.15 packs. Now you'll probably find it's quite hard to buy 0.15 of a pack. And if we buy 6 packs, we're not going to have enough. So we're going to have to go up to the next whole number. So we're going to need 7 packs. Question 7. Kofi works in a snack kiosk. Kofi has the following information about 90 items he sold yesterday. So ice creams, he sold 34 of those. Hot drinks, 12. Lollies, we don't know. Kofi wants to draw a pie chart to display this information outside the kiosk. Okay, right. And they've asked us to work out the size of the angle needed to represent the sales of lollies. Well, first of all, we need to know how many lollies we've got. Well, if there's 90 in total, what we can do is take these off from the 90. In fact, what I'm going to do is I'm going to add these two together first. So 34 plus 12, that gives us 46. So that means that the lollies is going to be the total, with the 90 minus the 46. Put that in the memory. So 90 minus 46 gives us 44. Okay, we want to know what angle we're going to need. Now, they're not actually asking us to draw a pie chart, okay? So you don't need to get your compass, but if you think a pie chart, you can have a circle like this, we'll have a center to it, we'd have a starting point up here, and each part of the pie chart would represent the different items. Okay, so you don't need to do this, I'm just doing it to see if it'll help. Right, well, we know that we've got 90 items in total. So we want to know what part of that, or what sort of proportion of that, is for lollies. Well, for lollies, it's 44 out of 90. Okay, that's the fraction of the pie chart that we need. Well, we've then got 360 degrees in a circle. So if we multiply the fraction by the total number of degrees in a circle, it should tell us the size of the angle we need for lollies. So 44 divided by 90 times 360, and we get 175.99999, so we can round that up to 176 degrees. And that looks sensible, because 44 is just under half of 90, and that's just under half a circle, which would be 180. Okay, so if you were doing it, you'd then get your protractor out and you'd probably measure something like this. So that would be your lollies. Then hot drinks, you could do something similar. So again, I'm just doing it as a quick sketch. Hot drinks would be something like that. And ice creams up here. Okay, but what we would know is that this angle is 176 degrees. Okay, so you don't need this at all. But hopefully it just shows you what you would do, or if you moved on to level 2, this is the kind of thing that you'd then need to work out. Question 8. Dion sells comics online. On Tuesday, there were 56 orders from customers. 3/8 of the customers used vouchers when they paid for their orders. Dion thinks 23 of the customers on Tuesday used a voucher. Is Dion correct? So what she's saying is she wants to know what 3/8 of, or times, 56 is. So we're going to 3 divided by 8 times 56. 21. Well, that's not equal to 23, so is Dion correct? No. She is incorrect. Question 9. Here is an accurate net of a cube drawn on a centimetre grid. So we've got a cube and we've sort of unfolded it or flattened it out. Work out the volume of the cube. Remember to state your units. Right, well, the volume of a cuboid is the length times the width, because that will give you the area of a rectangle, and then you multiply it by the height. Now, the thing with the cube is that all of the lengths are the same, so this is going to be the same number multiplied by itself 3 times. It's a centimetre grid, so we can just count how long this is. Well, it's 1, 2, 3. And let's say every measurement is going to be the same. So it's basically 3 times 3 times 3. 3 times 3 is 9, times another 3 is 27. And because it's volume, it's going to be centimetres cubed, because we multiplied 3 of the dimensions together. Question 10. Charlie is planning a new room in a hotel. He has a diagram of the room drawn on a grid. Charlie needs to show a space for the wardrobe. And we're told the space for the wardrobe must be rectangular in shape, 1.5 metres by 0.75 metres. So let's draw a quick sketch of that. So 1.5 metres by 0.75 metres. Have the longest side against a wall. So this is the longest side. It's going to be against one of the walls. Be at least 2 metres away from the doors. Be at least 2 metres away from the bed. Draw a space for the wardrobe on the grid below. So we've got our picture here, and the most important bit is this key down at the bottom. We're told that 1 centimetre on the grid represents 50 centimetres in the hotel room. Okay, so we're working with centimetres here. So what I'm going to do is I'm going to convert my measurements up here into centimetres. I know that we've got 100 centimetres in 1 metre. So if I multiply that by 100, it should give me the length in centimetres. So 150 centimetres. And the same with this one. Multiply it by 100. So we've got 0.75 times 100. We've got 75 centimetres. Okay, great. Now, let's say the key says 1 centimetre on the grid represents 50 centimetres. So what we can do is say, well, if we divide these, so what that means is that is 50 centimetres. That's what they're telling us with the key. Okay, so if we want to represent something that's 150 centimetres long, well, we want to know how many 50s go into 150. In other words, 150 divided by 50. So 150 divided by 50, that's 3. So that's going to be 3 boxes long. And we can do the same for the width. But the width is only 75 centimetres. So if we divide 75 by 50, we're going to get 1.5 boxes. So 1.5 boxes wide. Okay, so let's draw another little sketch. So the same as what we've got at the top, but instead of centimetres now we can say, so this will be 3 boxes and 1.5 boxes. Right, so we know how big the wardrobe is. We know we need the longer side against a wall. It's got to be at least 2 metres away from the doors. Well, let's convert we converted our other measurements into centimetres, so let's do the same with this. Well, 2 metres, if we want it in centimetres, it's going to be 2 times 100, which will be 200 centimetres. And this is going to be the same. Okay. So with this one, we can also say, well, how many boxes is that? Well, 200 divided by 50 is going to be 4 boxes. So we need the wardrobe to be at least 2 metres or 4 boxes away from the doors and 4 boxes away from the bed. Right. Well, the doors are down here, so 4 boxes are 1, 2, 3, 4, because we've got the door over here as well. So actually what I'm going to do is just draw a line straight across and say, well, it can't go in here, because that would be within 2 meters of the doors. We also need 4 boxes away from the bed. Well, we've only got 2.5 boxes, so we definitely can't go in that section. What about 4 boxes this way? 1, 2, 3, 4. So, and how far can we draw this down? And 4 this way would be sort of halfway. 1, 2, 3, 4. Okay, so in theory there's a tiny little gap. So it can't go in any of this space because it's 4 meters from the bed. We've got a tiny space here, but the wardrobe's not going to fit in there. We need the longer side against a wall. So the obvious bit seems to be this nice long wall here. And we know that we've got, if I pull this down, it needs to be 3 boxes by 1.5 boxes. So maybe we'll just put it here. So 1, 2, 3, and we need to come out 1.5 boxes. 1.5, 1.5. Right, so this is our wardrobe. Okay. Now we could move it anywhere along this wall, or we could even turn it and have it against this wall here. But this is the only space that we could fit it in. And finally, we've got question 11. Write 70% in figures and symbols. So, figures, that's 70, and symbols, %. So don't overthink it. If you think, oh no, what do they mean? 70%, nice and straightforward. Okay, Ahmed works in a museum. Last year, there were 680,000 visitors to the museum. This year, the museum was closed for 3 months. Ahmed expects the number of visitors to be 25% less this year than last year. Work out the number of visitors Ahmed expects this year. Right, well, the first thing we want to do is turn this from words into numbers. So 680,000. So 680,000. Now it's going to be 25% less, so let's work out what 25% of that is, and then we can take it off. So we're going to do 25 out of 100, multiply it by 680,000. So 25%, which is 0.25 as a decimal, multiply it by 680,000, and we get 170,000 visitors. Right, we now need to take that away from the original, because it's 25% less. So we can do 680,000 minus 170,000. So I'll put that in my memory. 680,000 minus, and we get 510,000. Oh, can't spell. Visitors. And that's the end of the paper. So hope you did well on that one. Make sure you like, subscribe, have your notifications turned on to get updates when I add more videos. Ask me any questions you've got on the channel, and hope to see you again soon. Thank you.